All right, welcome back to SCIAPS. We're here with the X-ray now. We just got done talking about laser. Let's move over to X-ray. What we're showing here is what we've just introduced, and we're gonna be making a big splash at, hopefully at ISRI in a couple of weeks. Is we've done a few things with the X-ray unit. As you guys know, X-ray's always been good. All the X-rays are good on stainless. They're great on high temps. That's really the heart of X-ray. It's historically X-ray's been pretty slow and not a great sorting tool for aluminum alloys, and that's because a lot of the X-ray guns out there don't measure magnesium or silicon all that well, especially magnesium. So we've come out with a design that really optimizes the magnesium and silicon measurement, and it's a lot better, it's a lot faster, and we've also, as part of that work, we've got a new tube in here that operates at a much higher power for the magnesium measurement. And we've also come out with what's called an aluminum app. So if you're just doing aluminums all day long, you can just go to the main screen, you can choose aluminum, and you can start testing aluminums. If you hit something that's not aluminum, it will warn you and it will analyze it as if it was a general piece of material. So you're not going to mess yourself up there. But anyway, that's what we're going to be talking about. It's great extra off and everything, but it's really good on aluminum, best in the industry. We're going to give you a couple of demos here to make that point. So let's start out with a very common mix-up. We see this all the time. Let's shoot where'd it go? Let's shoot our 6063. So what you'll see in this analyzer will now do, it'll measure down to 0.2% magnesium in 2 seconds. So, and we also measure the magnesium first, because when you're looking at aluminums, magnesium, silicon, copper, zinc, manganese, chromium, those are the key elements to analyzing most aluminum alloys. So let's go. Let's just show how quick this thing is. Pull the trigger, 2 seconds, 6063, and you see you've got your 0.4 or so percent magnesium. Do it again, couple of seconds, 6063, about 0.4 or so magnesium. Very quick. You go to an 1100. 1100, there's no magnesium in this. Pull the trigger, very quick, aluminum, no magnesium. Do it again, 2 second test. There you go, no magnesium, or very, very little. So what you see with this is that this is a common mix-up, because you really need to see that 0.4, 0.5% magnesium in the 6063. And if you can't see that, these are easily mixed up. And a lot of the old X-ray guns took 30, 60 seconds to do it. We're doing it in 2. So there you go. Very fast magnesium is the key to sorting these guys. Once you get to higher mag, like here's a 5052, it's even faster. Again, in a couple of seconds, you get your 2.5% or so magnesium. There's your 5052. You also get your nice chrome chemistry as well. You get your low iron. So let's move on to an even harder one, since we did that one pretty well. Let's go to a 356, 357. These differ by, this has around 0.3, 0.4 magnesium. This has around 0.7, 0.8 to 357. Yeah, so they only differ by a few tenths of a percent mag, and they're lower, 0.3 versus 0.5 or so. So let's do this. Again, we'll see the magnesium in just 2 seconds. So point the trigger. There's your 356. There's your magnesium. Let's do it again, so we didn't just get lucky. There it is again, around 0.2, 0.3%. All right, let's move to your 357. There you go. That's a little higher. All right, do it again, so we didn't get lucky. There you go, about 0.5%. So let's scroll back and just to look at this. This is really, really nice. Go back to the 356. Here's the 2 tests. 0.2, 0.3. Was there a third one? No, that was the 5052. That was. But you can also see silicon at 7.7, 7.6. Again, in a 2 second test, there's your other alloying elements. A little low manganese, iron at 3.3, 3.3 again. So in a couple of seconds, you're really doing a great job on these things. Here's your 357, again at 0.5 in a 2 second test, 0.58, 0.54. So what we've done with the aluminum app is we've basically done the opposite of how the rest of the industry sorts aluminum alloys. What the other guys do they shoot it with a high voltage beam, like it's a high temp, and then they'll move to the low voltage beam if they want to measure silicon or aluminum or magnesium or whatever. What we know for aluminum alloys is if you can measure mag, silicon, obviously aluminum, vanadium, chromium, iron, manganese, copper, nickel, zinc, if you can measure those elements in a single quick shot, you can sort almost 90% of your aluminum alloys. So what this guy does is it does that. 2 seconds, done on 90% of your aluminum alloys. The occasional alloy that needs the second beam, the high voltage beam, where you want to measure zirconium, like if it's a 7000, silver, if it's a 2000 lithium alloy, or tin, or what else, bismuth or lead, then it goes to the second beam only for those. So it's smart enough to know when it needs 2 beams versus 1. So now you have the aluminum map that'll do almost all your aluminum alloys in 2 seconds because of the really outstanding magnesium performance. And when it needs to go to that second beam, it'll do that. And really now you're looking at sorting every aluminum alloy in anywhere from 2 to 4 seconds. And then nothing comes close to that in the marketplace. So let's see, what else could we do? We've done those. Let's do another. Here's a common mix-up. Let's do 3105. Again, a couple of seconds, it can be done with that. Do a few repeats just to show the repeatability. And these are only 2-second tests on the magnesium there. All right, let's look at that. 3105, you got 0.54 mag, 0.41 mag, 0.41 again, silicon 3.7, 3.4, 3.4 again. So again, for 2 seconds on magnesium, that's a really, really good result. If you scroll down, the key alloying element in 3105 is manganese, so you got 0.6 there. So look at that, 0.603, 0.601, 0.597. So this thing is really, really doing a nice job on that manganese and the magnesium, which are the keys to there. Switch over to 6061, same thing, couple of seconds test. There you go. Do it again. Do it again. I don't mind. And look at that. There's a magnesium, 0.89, 0.88, 0.87. So repeatability to within a 0.01%, all with a 2-second test on an X-ray gun. I mean, that is better than. It's going to sound like heresy. That's better than Lib's performance. All right, one more test we're going to do, and that's to show how the analyzer knows when to use the second beam when it needs to do that to uniquely identify the alloy. So let's do a couple of 7000s. This is 7075. So this you're going to want to see the zirconium to really make sure. So you'll see now it's rolling over to the second beam, and it's getting the 7075. So let's just do that a few times. First test, all right, because it hasn't seen the zirc, it's unsure, but then it rolls to the second beam, and now it knows. So the good thing about this this algorithm is it knows when it needs the second beam. The operator does not have to know this. All right, so most of the tests it'll finish after 2 seconds because it knows. The tests where it needs to measure some of these higher atomic number elements like lead, bismuth, zirconium, silver, tin, a few others, it'll automatically roll over to the next beam. And kind of what I like about this is, again, on that 2-second chrome test, it's really, chrome's another important alloying element. You're really looking at tight precision, 0.17, 0.178, 0.174, so it's really, really tight. And then let's do one more. Let's do a 7050. Same story there. It's going to recognize instantly that it needs the second beam, so it switches over and gets your ID. So you can have it set up to just show the top match. You see that's a very big difference between the two matches. The match number 91 versus 78, and it'll call it 7050 every time. So again, it knows it needs a second beam, and there you go. So, in summary, all these X-ray units are great on stainless, high temps, turnings, specialty alloys. They're all good on that. Historically, a lot of the X-rays have been not so good on aluminum alloys. Why? Because they don't make a good measurement of magnesium, and silicon, but more importantly, magnesium. And that mag measurement is critical to having a really good aluminum alloy measurement. So we've just turned things around. Everybody else does it one way. They measure with one beam and then they measure with a second beam. We've turned that around. We've come up with this aluminum app and a higher powered X-ray tube. And what we do with that app is we measure magnesium, silicon, chrome, manganese, iron, copper, zinc, a few others. What am I forgetting? Vanadium, titanium. We measure all those first, because what we realize is if you measure those 8 or 9 elements first, most of the aluminum alloys you can identify in about a 2-second test. Because this is so good on magnesium, like we showed, you can measure down to around 0.2% magnesium reliably in 2 seconds. You can really see almost all your alloys and identify them uniquely. The analyzer, we've also made it smart enough that if it cannot uniquely identify the aluminum alloy after that 2-second test, it extends the test 2 more seconds at a different X-ray tube setting, and then at that second setting it'll measure things like bismuth, lead, tin, silver, zirconium, which then fill out the element suite and allow you to identify the alloy. So I would say, depending on your facility, 70 to 90% of the time you're going to be able to sort all your aluminum alloys in 2 seconds with this device. Compare that to the older devices that were 20, 30 seconds, a minute. I mean, the older ones can't even measure the 0.2, 0.3% magnesium in some of these. And then there may be a few of these aluminum alloys where you need to measure zirconium, like a 7000, or tin, maybe silver if it's a lithium containing aluminum alloy, in which case it might take that extra 2 seconds. So almost all the time you're going to be done in 2, sometimes taking 4. That's way faster than anything else, and by far the best performance on aluminum. So if there's one reason to get this unit over the other ones, it's the aluminum performance for sure.